Welcome to the Pharmacy Inspection Podcast, powered by lyceumce.com, where we discuss topics related to both sterile and non-sterile compounding pharmacy in an effort to promote compliance and increase quality. Please welcome your hosts, Brian Prince and Seth DePasquale.
Hi everyone, this is Seth DePasquale, board certified sterile compounding pharmacist. Happy Friday everyone. Since it's Friday, that means another special edition of the Pharmacy Inspection Podcast. Every Friday we look at a 483 to try to help us understand and learn more about compliance within sterile compounding. So let's jump right in. The learning objectives for today's 483 are, by the end of this you should be able to explain the purpose of viable air sampling, and discuss how conclusions can be made from the results of viable air sampling. So this week's 43, we're going to focus on viable air sampling, which is one part of an environmental sampling plan. The information gained from the viable air sampling can be very telling of the cleanliness and control you have over your clean room. In this particular 483, viable air sampling was performed by a third-party testing company for the purposes of re-certifying the clean room. Here's what the observation said. You did not make adequate product evaluation and take remedial action where microbial contamination was found to be present in the ISO 5 classified aseptic processing or areas surrounding the ISO 5 classified area. Specifically, according to your firm's certification report dated 16 April 2019, a viable air sampling revealed in the hood taken at the center approximately 6 inches from the rear. The bacterial results and trending were that there was 19 CFU found and were identified as Bacillus, coagulase negative staphylococcus, and micrococcus. So I'm really just going to focus on the ISO class 5 area. So I'm going to skip down to finding B of the same observation, which is, according to your firm's certification report dated October 2019, a viable air sample revealed in the laminar airflow hood at the center approximately 6 inches from the rear, 1 CFU were identified as Bacillus. So if you're unfamiliar with viable air sampling, it's the type of sampling where you use a piece of equipment to draw in a known volume of air and impact the air on a plate of growth media to see if there's any microorganisms in the air. This 483 states that a third-party contractor had done the viable air sampling inside their ISO 5 engineering control or their hood and in the ISO 7 buffer room. What's interesting here is that the 483 shows the results not just one recertification, but the inspector reported a second certification 6 months later as well. What's most concerning is that the April 19 results were there were a total of 19 CFU or colony forming units. However, 6 months later, while there were still microorganisms found in the air in the same location, it was much less, with only one found. Again, let's continue to just focus on the ISO 5 location, as this is the most critical part of the clean room, as this is where compounding is performed. In either case, April and October, an investigation should have been done in the clean room to figure out what the underlying issue is. I encourage you to go back and listen to podcast episode on investigations and CAPAs for learning how to properly investigate and document microbial excursions. In this 483, because it was a third-party contractor, they also reported the type of organisms present. This can be extremely helpful in finding out the root cause of the contamination. In April, 19 CFU were found, and they were Bacillus, coagulase negative staphylococcus, and micrococcus. So here in the post, I've put in a table for the action levels of viable air sampling. That's found in USP 797, and it basically says that in an ISO class 5 area, if you have greater than 1 CFU in your ISO class 5 area, you need to perform an investigation into what that CFU is at minimum. So the fact that in April 2019 there were 19 CFU found, an investigation absolutely should have been performed. Looking up where these particular microorganisms come from would be the first step in an investigation. Bacillus are gram-positive bacteria that are usually able to form spores, which are highly resistant when they're in their spore form. Bacillus can be found in soil or it can be of animal origin. Coagulase negative Staphylococcus and Micrococcus are typically normal flora found on humans. This information gives us two possible places to look for ingress routes for these organisms: materials and people or operators inside the cleanroom. Remember, these were found in the ISO Class 5 engineering control, which is supposed to be extremely clean and basically free from microorganisms at any given time. So this could also suggest that maybe there's something wrong with their engineering control as well, as it should be actively pushing microorganisms out of the hood. In the post here, I've put in a cause and effect diagram, otherwise known as a fishbone diagram or Ishikawa diagram, for looking at possible causes of contamination. So I encourage you to look at the post that goes along with this podcast episode, because there's a lot of pictures and things that I've embedded in the post that'll be very helpful for looking at this 43. In an investigation, we would possibly look at the gowning procedures for operators, cleaning procedures like what agents are being used, the frequency of cleaning, the type of materials being used to clean, operator technique while inside the clean room, our process for bringing materials into the clean room, and the engineering control itself. Is it working properly? Is there enough airflow? Is there anything wrong with the HEPA filters? 6 months later, when the recertification was done again, there was only one CFU of Bacillus found in the ISO 5 hood. This suggests that the firm did possibly investigate the cause of the contamination and made some improvements. However, there was no documentation to be found that to definitively say that that was actually done. I will say it might have been helpful if there was also results from surface sampling a hood, as this might give us further indication of what is actually causing the contamination. So without sharing the entire 483, there are other key issues that were found that suggest other possibilities. For instance, Observation 2 notes that cleaning is performed in the ISO 5 area with non-sterile cleaning agents and wipes. Observation 6 discusses how there's a loose light fixture inside the ISO 5 laminar airflow hood. Observation 8 points out that prior to entering the clean room, some materials were not disinfected. In Observation 9, it's discovered that there's signs of rust and chipped paint inside the ISO 5 laminar airflow hood. Needless to say, there's a lot of issues that we can look at and remediate to fix the underlying contamination. USP 797 says data collected in response to corrective actions must be reviewed to confirm that actions taken have been effective. The corrective action plan must be dependent on the CFU count and the microorganisms recovered. Some examples of corrective action include the process or facility improvements, personnel training, cleaning and disinfecting, or HEPA filter replacement and/or repair. The extent of the investigation should be consistent with the deviation and should include an evaluation of trends. The corrective action plan must be documented. Again, this is found in USP 797, data evaluation and action levels. The point I'm trying to make here is that there's an abundance of information for us to find and remediate the root cause of this particular contamination. The abundance of CFU found in the April 19 certification should have prompted the pharmacy to fix at minimum. Cleaning material agents and frequencies should have been examined, possibly no longer using non-sterile wipes to clean and disinfect the hood. Operators' gowning should be examined to see if people are gowning properly and if the gowning itself is sufficient, meaning is their skin exposed while inside the laminar airflow hood. And the visible rust and other issues with the ISO 5 area should have been remediated. Another point to be made is that viable air sampling is only performed every 6 months during recertification of this clean room. Perhaps the first results, where there was 19 CFU found in the ISO 5 area, that should have also prompted more frequent viable air sampling. No follow-up was performed until 6 months later, so it's hard to make the case of any trend taking place when the data points are 6 months apart from each other. Follow-up viable air sampling most definitely should have been performed to see if any of the improvements actually did remediate the issue. Also, sterile operations didn't cease when there was 19 CFU found, which calls into question any of the batches that were made in the hood between April of 2019 and October. Lastly, I'd like to encourage pharmacies to perform their own viable air sampling. These sampling devices range in price usually from $5,000 to $10,000, but can absolutely give you more data to defend your operation from batches being called into question for sterility concerns. The point here is that the pharmacy should have made the purchase of a viable air sampler, made improvements, then performed viable air sampling while compounding operations took place. Had this been done, you could have seen a real trend line, and further analysis could have been done while certain fixes, like more cleaning, training operators, retraining operators, different garbing, engineering control examination were taking place one at a time. In compounding pharmacy, the one thing that is not taken as seriously as it should is an environmental sampling plan. It's evident that had the pharmacy more closely examined the findings from the first certification in April 2019, there may have not been an issue at all found in the October recertification. If you'd like to fully explore how to implement an environmental sampling plan that makes sense for your operation, I'd suggest looking at the environmental monitoring course available here on learn.lycemce.com. It's available for free, or if you'd like continuing education credit along with the lesson, you can take that here as well. So that's all I have for this week. It's been another great week here at lycemce.com. Putting out a lot of posts and more material for you guys to help with your compliance with 797. So until next time, I'd like to wish you a happy weekend and keep raising the bar.
The Pharmacy Inspection Podcast is powered by lycemce.com, where you can find engaging video-based continuing education programs, as well as a social community for pharmacists and technicians. Join one of the discussion groups or forums and post your questions to the group. Lyceum CE, where fun CE gets done.